Okay, so last week we discussed about the classification according to the physical size, and we went through the supercomputers and mainframe computers, right? And we are about to talk about mini computers. Yeah, so I think we have written the stuff regarding the mainframe, right? Yeah, great. So when it comes to the mini computers, it is like, even though the word is mini, it is not mini as we thought, right? So the computers that we are using today, the personal computers, are not in this category even, right? So like it is going to be in a category like after this one, which is called the microcomputers. So even though this is called mini computers, it is big in size, considerably big, not like big as a mainframe, but it is big. And it has the ability of maintaining some different number of terminals or some different number of computers, like in a small network, right? Like acting as a small server, right? So as they said, these computers are used in medium scale institutions such as banks, right? So like if you take one particular branch of a bank, those things will be maintained by a mini computer, right? So it's kind of a server, right? Which has the ability of serving different number of computers through a network, right? So as you can see, the diagram explain it. So the mini computer is right over here at the bottom. So the terminals are there to have the idea or have the services which is given by the mini computer. All right. So like there were supercomputers, there were mainframes, and now there are mini computers, right? So after the mini computers, we have the microcomputers, where our particular computers or our devices or the normal devices that is used by the general public are category under this particular category, right? The microcomputers, like starting from the desktop, moving to the tablets, the mobile devices, and all these smart devices, everything category under this particular category, which is called the microcomputers. So now there are 4 types that you have learned: supercomputers, the mainframes, mini computers, and the microcomputers, right? So let's quickly write down the things regarding the mini computers and the microcomputers, right? So have the subheading mini computers. Right, so you may write down this sentence. Yeah, these 2 are important as well. So it's almost everything. So just write it out, people. Isira, we are just start writing. So we had the subheading called mini computers. and we were copying these things down. Let me know when you are done, people. Oh, Udana has done finished writing. How about others? Okay, Rizwan as well. Others, keep writing. Let me know when you are done. Yes, Rizwan. I had to stuck at the middle of my traveling, so I'm doing this from the institute. Okay, so how about the writing? Is there anyone still writing the note? All right, so, oh, Maritu, okay. All right. Please indicate me when you are done. Okay, so let's move to the microcomputers as well. Yeah, regarding the microcomputer, let me write down these things. Yeah, it's better you write down the entire thing, people. Yeah, some people just connected with us. So the people who have just connected, we end up with the third one, which is the mini computers. You better write down the things under the mini computers in your textbook, or like later you can refer it from the recording. And we are writing about the microcomputers for the moment. The one can you see on the screen? Okay, 2 are done. How about others? Okay, anyone who is still writing? All right, I'll be waiting. Let me know when you're done. Okay. Anyone who is still writing? All right, so let's move forward. Now we came to these topics because we were done categorizing, or like we did categorizing the computers or classify the computers according to this particular criteria, which is regarding the physical size. And regarding the physical size, we met these 4 categories: the supercomputers, mainframes, the mini computers, and the microcomputers. And when we are categorizing a computer according to the technology, we find the analog computers, we find the digital computers, and we find the hybrid computers. So like analog computers means the computers which work with the analog signals, such as environmental parameters, like the light, speed, the temperature, the pressure, right? Those kind of things. So all these things create you an analog signals. Now analog signals, we say that analog signal has a wave kind of form, right? Wave ekak wage kiyana, right? And as well as there are digital computers. Digital computers are the most frequent computer, like the most common computer that we are using, right? Even you and me are interacting through a digital computer, right? Analog computers are for some special purposes, right? So specifically when it comes to the weather department, they are using some particular devices which has analog computers, so they can measure the rainfalls, the temperature, the wind speed and all these things, right? So there are some specific things, right, which is made out of or which is made for specific tasks, right? So the digital computers are the most common one, right? We call it, we use it in day-to-day life to make our things easy, right? Especially when it comes to the data and information part. And the hybrid computers, in other hand, it is a combination of the analog and the digital, right? So when we are doing the first lesson, we talk about the ECG machine, which is a ICT application on the health sector, right? So ECG machine is an example for a hybrid computer, right? Because in the ECG machine, we have the sensors plugged into our body, right? And from the heartbeat, which is captured by the sensors of that computer. So like when it comes to the heartbeat gives you a sound. Sound is an analog signal. And according to that sound, you will be able to see a graph on a monitor. So when it comes to the monitor, it is a part of the digital computers, or like using a software, using some kind of a waveform or particular application is running. That means it is combined with the digital computer. So analog signal, which is the heartbeat, is being converted into a digital signal. So the digital data will be displayed on the monitor. So it is a combination of analog and digital signals. So the computers that has that kind of an ability is called hybrid computers, right? So those are the three ways or the three categories that we are dividing, or like that we are classifying according to the technology. Is that clear, everyone? Okay, great. So let's quickly write down these things. Classification according to the technology. Come up with the heading. Right, it's better you write this down, and like it's better you draw the analog wave after writing about the analog computers, right? So you may have an idea like what kind of a wave is this. Yes, Rizwan, it's better you draw the picture, which is about the analog signal. Sanushi, parameters means Sanushi. It's kind of the things like environmental parameters means like environmental factors, right? Like speed, pressure. Those are the example for the parameters, right? So write the things and draw the picture, people. Right. Are we done? Can we move to the digital computers as well? So people who have done with the analog computers, go with the digital computers. So the same way, and draw the digital signal as well. Right, Udan, you have to draw the diagram as well. All right, great. So Udan is done. Let me know, others. Let me know when you are done, right? All right, two are done. How about the others? Right, people. Is there anyone still writing this? Or can we proceed? All right. So we are moving forward. So the hybrid computers, the very last one of this kind. Yeah, this is enough regarding that. As well as go with the example people, otherwise you won't realize how it is being a digital signal and how the analog signal is converted into that. All right, one is done. How about others? Yes, others? Is there anyone who's still writing? Okay, Mihidi. Let me know when you're done. Yeah, reason like there is no such thing called hybrid signal reason. like it's only the conversion, Puta. Since the when we are receiving things from the heartbeat, like regarding the ECG, when we receive the heartbeat, it receives as an analog signal. So later we use a particular devices like modems or like some specific devices to convert the analog signal into a digital signal, right? So we don't have any signal called a hybrid signal. Hybrid computers are named as because they can have the ability of manage both the signals. That is why. Got that result? I'll show you one for the hybrid computer, right? Yeah. Hold on a second. So, is everyone done with writing? Anyone who is still writing? Okay, so right. So let's move forward. So for an hybrid computer, hold on. I show you one. I think I had something over here. There you go. Oh no, this is not. No, this only had analog and the digital. And this is one of the way that the analog computer is working. Right, it is receiving all the things in sensors. Right, this circuit is there to receive the sensors. So it shows how the sensors are working. All right, let me check one for a hybrid. Yeah, now they are using this hybrid term for the tablet that can be used as a laptop, but it is not the term that we are using here, right? So yeah, now this of course something can be shown as a hybrid one. Here the this doctor or this technician is checking the eyes of a particular patient, and they are using the light, an analog signal, and with that light they are receiving the data regarding the reflection. So they make it the reflected data on a computer screen. So light is an analog signal. Here when we are looking at it from the screen, it is converted into a digital images and all these things. So it is a hybrid computer, right? And yeah, if you think about how the pregnant ladies, the moms are being scanned, right? So they are using kind of a hybrid technology there as well. Yeah. They're not given any pictures regarding that, but this can be taken as a very nice example, right? The one that we saw already. Is that clear, everyone? Okay. All right, so let's move to the function of a computer system. Now, this, of course, you need to understand. I'll draw these things for you as well. So then I will be able to explain what really goes on with this diagram. Now, this diagram is called a nice name, which we identified as von Neumann architecture. This is given the von Neumann architecture because it is the von Neumann who has introduced this particular diagram for the first time to the world with the concept of stored program concept, right? So this is a much detailed view of a von Neumann architecture, right? When he was introducing when the von Neumann, the person von Neumann was introducing this architecture, he was just talking about the input devices, process, and the output devices. He was not specifically mentioned about the main memory and the secondary memory, but later it is extended, right? Now, yeah, let me illustrate what is going on with the von Neumann architecture and how we are going to memorize that in a very simple way, right? Okay, so let me take my whiteboard. Oh, not that. Okay, now this is what happens actually, right? Now, there are some devices which is helping to input the data into the computer, which we call the input devices. Now, later in this lesson, we are going to talk about these devices in detail, right? So there are devices like mouse, like keyboard, right? These things are called the input devices, right? So these input devices are the devices which helps to input data into the computer system, right? So when the input devices are there, so it will enter the details or enter when the data or a particular data is input by an input device, that particular data comes and stays with the main memory of the computer, right? So generally, this is the RAM that we are talking about, the main memory. All right, so instructions come from the input device to the main memory. So when the instruction is received at the main memory, it needs to be sent for the processing, right? Because data, when any particular signal, when we press a key on the keyboard, that particular data will be reached to the main memory and will be sent to the CPU to understand which key that the user has pressed, right? It's a very simple thing. It's a very simple task that is happening within few milliseconds, but this is what is going on with the computer, right? So from the input device, that particular data will be reached at the main memory. As well as there are data which resides at the secondary storage or the permanent storage of the computer, like the hard disk, right, is also has the ability of sending the data into the main memory, right? So when we store the data or store particular programs in the hard disk, which is called the secondary memory, right, has the ability of sending the data to the main memory as well. So whenever this data is reached at the main memory, what main memory is doing, he is sending the data to the central processing unit, which is the CPU, right? Or like the brain inside the computer. So the CPU is just the most important chip inside the computer, which has the dimension of like 2" by 2" kind of a chip, right? A microprocessor. So inside this, there are 3 main components, right? So I'll take a different color. All right, so inside the CPU, there is something called registers. So these registers are called the memory component inside the CPU, right? So whenever the data is reached at the main memory has the ability of containing a big amount of data, like in gigabytes, in megabytes. It has the ability of keeping that data. Registers are small in size, right? They have the capacity in kilobytes, so that megabytes of data will be decomposed into a small segments, and that segment will be sent to the registry in a very quicker manner, right? So in simple terms, main memory contains the bigger program. So like it may have many different instructions. So like instruction by instruction, data will be sent to the registers. Why it is being sent to the registers? Inside the CPU, there is another component called ALU, arithmetic and logic unit. Right, we simply say it is as ALU. This ALU is the one which executes the thing, or will executes the instructions in a real time or in a real way, right? Yes, Rizon, I think yeah, let me check that, Rizon. I think it's RI neither Kovalanda arithmetic. Yes, it is I. It is I. Thank you for that, Rizon. Right, so the arithmetic and logic unit. Right, so arithmetic and logic unit is receiving the data which is received by the registers. So arithmetic and logic unit, yeah, so the arithmetic and logic unit, I'll come to that reason. So the arithmetic and logic unit has the ability of maintaining or like handling the instructions which is received by the which is given by the registers and handle it in an arithmetical manner or in a logical manner, right? So when they have arithmetic details or arithmetic instructions, it will handle as an arithmetic operation. When it has a logical instructions, it will be maintained as logical execution or like logical operation. However, whatever the data that is being processed by the ALU, the result is given to the registers again. So from registers, it is receiving the instructions. So according to the instructions, ALU will do the execution. Then the result will be again returned to the registers. When the registers receive the result, it will direct the result to the main memory. So from main memory, it can move to two different locations. One particular location is the secondary memory. If we save something, it's going to stay in our secondary memory. That means the hard disk. As well as we can send the things to where? To the what is the color we are going to use? Brown? Yes, that's good. And we can send these things to the output devices as well. Right, so the result can be sent to the output devices as well. So registers and arithmetic and logic unit are inside the inside the CPU, the central processing unit. So it's kind of clear now how the things are going to happen. Now there is a problem, not actually a problem. Like when it comes to the computer, they are not going to work by themselves. These components are not going to work by themselves. They need to be commanded or managed, right? So to do their task, for input devices to act or like to send inputs, for the main memory to like keep the things inside it, and to send the details instruction by instruction to the registers, to arithmetic and logic unit to perform the arithmetical task and the operational, the logical task. Someone needs to be command them to do their task. And the commanding part is done by a memory, done by a component called control unit, right? Yeah, Udan, I'll give you the time, right? So the controlling part is done by a component called control unit. So the control unit will be there. So why the control unit is there? Because to send the control signal, right? So this is going to send the control signals for the each and every component, for each and every component in the computer system, or like in the system that you can find over here. So it is going to send a control signal to the arithmetic and logic unit. It will send a control to the registers, and it will send a control unit, a control signal to the input devices, as well as the main memory. Like each and every one, each and every component is controlled or like is commanded by the control unit, right? So here from this side, a control signal is given to the output devices, as well as a control signal can be sent to the secondary storage as well. Right. So here comes the von Neumann architecture. So this particular components, these things will be identified as the CPU, the central processing unit, right? So in your diagram, the dotted lines are the data or instructions, and the single lines are called the command in the diagram. They had another name, command, and the control, yes, or the control. Okay, so this is what we call the von Neumann architecture. Are you clear with this story? Right, great. So before we come to this diagram, it's kind of a different spelling reason. It's like von Neumann. I'll show you the because since it is a French name, the way we are going to write it is a little bit different reason.
Sir, is it John von Neumann?
No, yeah, it's John von Neumann, yes.
He's a Hungarian American mathematician. Sir.
That's right, yes. So let's go with the heading, function of a computer system. And you may write this sentence. Yeah, Sanushi, in simple terms, like when the CPU is given some calculation, like in simple terms, if you ask it to add two numbers together, that is what we call arithmetical operation. And when it comes to the logical operation, it's kind of a comparison, right? Like to get to know whether things are equals to each other or like not equals or greater than or less than. Those are called the comparison, right? Or the logical operations. As well as like when it comes to your fourth lesson, you will find like when it comes to the computing, there is an area called Boolean Algebra. And in Boolean Algebra, you will be find some other logical operations like and, or, and not kind of operations. Like those are something new for you. So you will get to know about those things in the fourth lesson, right? So for the moment, just remember like the arithmetical stuff and this comparison and the logical stuff. Right? Okay. Right. So if you are done with this, you can draw the diagram. Draw it carefully, people. I'm keeping this the diagram on the textbook, so it's better you understand it. Be careful with the lines. Yeah, Sanetma and Sedini, are you talking about this particular one? Okay, there you go. Okay, one is done. How about others? Okay, two are done. Okay, is there anyone who is still writing? Okay, Mihini, keep writing. Let me know when you are done. People give me a second, I'll be right back.
Done, sir.
All right, are we done? Can we move forward? Anyone who is still writing? Right, great. So yeah, let me see whether we have anything to write on this particular place. No, we really discuss about this, and you know how the things are happening. So you don't need to describe it like this. Yeah. So we can jump into the place then after, which is where we are going to experience the physical components of a computer system. So these things, there are some things that you know already, right? These things like, these are some general stuff for you. So we just run through this, right? And just get to know how the things are going to happen. And later by next week, I'm going to show you how to assemble a computer. I had this small game regarding the assembling simulator, right? So we can see it by next week. If I start it now, it will take time, right? So let's get to know about these things. Then we'll see how we are going to assemble a computer, right? So the first thing is regarding the input devices, something very easy. So we use these devices to input the details or input the data into the computer, right? So the main input device or the major input device is considered to be the keyboard. So when you are not connected, when you are not connected with a keyboard, when the CPU is not, I'm sorry, not the CPU, the system unit is not connected with the keyboard, the computer will not boot. It will just give you some beep sounds indicating the basic or the major input device is missing in your computer, right? So keyboard is considered to be the major input device. So in the keyboard, there are several different things that you need to know, like regarding the keys. So there are numeric keys, there are characters, right, which we are using for the typing, right, which we call typing keys as well as there are some function keys at the top, which is from F1 to F12, right, and some special keys as well, right, like the tab key, like the caps lock key, like the shift key, those kind of things. Now, if you look into your keyboard in the computer, you can see all these things, right? And the other special, like regarding the other special keys, you can take like the scroll lock, the caps lock, right? The num lock keys as well, right? So when it comes to the control keys, it helps you to control the things. So you can consider the window key, as well as, not the window key actually, window key is a special kind of key, the ALT, the alternate key, the alter key, and the CTRL, the control key, and the space bar, right? And there is some another keys called home key, end key, page up, page down, insert, and delete, right? If I show you some clear picture about the keyboards, there you go, right? Now what you can see at your left hand side are some modern keyboards, right? This particular one is made in a way that you can type easily, right? What you can see at your left is a laptop keyboard with the circuit, right? And these keyboards are some old keyboards which we were using, right? Some basic functionalities are there, but not all the things are there, right? So we use the keyboard to do what? To give a character input, right? So that is regarding the keyboard. And then after, there are some things called pointing devices. So the famous mouse, right? The one which we are using in a very frequent manner is named as a pointing device, right? So this pointing device is helping you to point the things, right? So the pointing part cannot only be done by the mouse. There are many other devices which helps you to do the pointing. So when it comes to the mouse, like mouse has 3 major buttons, like the left mouse button, right mouse button, and the scroll or the mouse wheel, which we are used to scroll, right? And when it comes to the gaming mouse, there are some different kinds of buttons as well nowadays, like for firing, for the toggling, right? As well as there is something called some other buttons are there for the connectivity as well, right? But generally, when it comes to the mouse, it has 3 particular buttons, right? As well as the touchpad on your laptop device is replicating or like working in the very similar way that the mouse is working, right? So the only difference is mouse, it has specific buttons and all these things. Touchpad, there are like we are going to handle that from our index finger. And when it comes to the mouse, there are many different types, like the wired mouse and the wireless mouse, right? So when it comes to the wireless, the connection is always made, or like in most of the time it is made by Bluetooth, as well as there are mouse which has the connection with the infrared as well, right? They use infrared signal to have the connection as well, right? And when it comes to the touch screen, it is also a pointing device, but actually the touch screen can be considered as both input and output, because touch screen is a place where we are used to see the details from a particular computer or from a device. So when we are taking the data out from a particular device, it is considered to be an output device as well. But when we are pointing or when we are touching the touch screen to give some command, then it can be considered as an input device as well. So touch screen is kind of a device which acts as an input as well as an output, right? And you know about this, right? The joysticks or the game controllers, right? It is also kind of a pointing device that you have, right? And when it comes to the game controllers, most of the game controllers are connected with the infrared, right? And the light pen, I think some of you may have seen this, right? Or the touch sensitive pen, right? So, or the stylus, sometimes we say. And light pen and a stylus, it has some differences as well. But in most of the cases, we use it to do the pointing. Now, the whiteboard that I am using on my computer, I'm using a stylus which is touch sensitive to draw these things on my screen. I'm having a touch screen, so I can draw things using my stylus, right? So it is a work of a light pen when it comes to the modern technology, right? So light pen is generally used for these computer aided designing tasks, right? So you can, or the architecture will be able to draw things using this light pen. And as well as these are the devices we use to input images and videos, right? So digital camera, it is obvious you know about it. Now it is very rare to see digital cameras now, because you guys are taking pictures from your mobile phone. So mobile phones seems to be having much advanced camera into it, right? But somehow a lens with the device, right? So when the device has a lens and it has the ability of capturing, so it is working as a digital camera, right? So we take the inputs from the lens, so we can take it as an input device, as well as we can see the things from this little screen. So at the same time, this can be considered as an output device as well. But when we are trying to put the images that we captured through the digital camera to the computer, then the digital camera is working as an input device, because digital camera's memory chip is going to have the particular details of the captures or the images that we capture. So with that, the data can be transferred into the computer. And the webcam, that all of us are very knowledgeable about the webcams now, right? Since we are doing these video conferences through Zoom, through Teams, through Google Meets kind of things, right? So we know what's the function of a webcam. It allows you to give you a video input, and it is very important when we are doing a live video or a live session. So we will be able to interact with the audience or the participants in a video format, right? So when it comes to the webcams, most of the mobile devices has inbuilt webcams, and the standalone computers like desktop, they don't have a webcam with the monitor. In most of the cases, we have to purchase a webcam separately, right? So webcam can be connected to the computer using a USB port, right? So it will allow you the function to do so. As well as the CCTV, it is something advanced kind of technology which we are not using with our general computers day to day, but capturing the surveillance or like making the security around any premises, CCTV matters. So when whatever the thing that CCTV is captured will be sent to a computer, and sometimes it is being processed into some particular format, then will be stored inside it. So the digital camera, the webcam, the CCTV, all these things has the ability of capturing videos and still images, both. But when it comes to the scanners, it has only the ability of capturing the still images, not the moving images, right? So there are different kinds of scanners, which we call the flatbed scanner, the one that you can see on the screen, right? So in a flatbed scanner, we have very limited space to do the scanning. So the thing that we are going to scan should be at the maximum of A4 or maybe A3 size, right? So there are much bigger scanners, but it's not used in very occasionally. And you can have the barcode readers, right? So which can read or which can scan a barcode, right? Which you have seen already on some supermarkets, right? And we can have MICR. Now, MICR is a special device where it used mostly in the banks to recognize whether a check leaf is a genuine one, right? Because the check leaf contains the characters which is written by a magnetic ink, right, at the very bottom of the check leaf. So that particular magnetic ink can be recognized by the magnetic ink character reader, an MICR. And the OCR is there for optical character recognition. Now, there are two devices that they are showing over here. One OCR is kind of a scanner. We feed the things from the top. It scans very quickly and send the particular paper like through it. When we insert it at the top, we will be receiving the same document from the bottom. Meanwhile, the scanned picture is given to the computer or is fed to the computer, right? And the one that is held by the hand is also an OCR, and it helps us to read character by character from a particular document. So the beauty of OCR is when we scan something from the OCR, we will be able to edit that particular scan character by character. That is why it is called optical character recognition. And optical mark recognition, the OMR, is there to recognize the marks, right? This is specifically used to mark the MCQ papers on a general exam. So in the O levels, you will be receiving a sheet, something like this, where you are going to mark the correct answer from a pencil. So later through an OMR, your answer script will be read within a second and will be output how many that you got correct, right? But when you are doing the scanning through a OMR, they are advised you to mark just one particular answer from the answers that you are given on the answer sheet. Yes, Rison, do you got
Sir,
any question?
yeah, sir. If like, if there were some mistakes in the OMR, if we mark something wrong, are they anyway checking the paper again?
Yeah, like first they check the OMR, like they check the OMR time to time, and they keep the track whether the OMR is reading in a correct way. In case if we got the suspicious point, they check it manually, right, and reconfirm the things. Anyway, the things that you have marked will be checked by several different markers, not just by your one, right? So it goes on that particular manner.
Okay, sir. Thank you, sir.
Right, okay, right, okay. So the next example is the ATM. So ATM actually, it reads a ATM card which has a magnetic stripe on it, right? And related to that particular ATM card, the things will be shown and the access will be given to the particular account. As well as we use microphone to give a audio input. Right. Okay, so people, since it is 5:1, our time is up. We'll write about these input devices like as the headings, like the examples, when we meet next time, right? I'm quickly going to end the session because I have to run to my other class at home, right? So which way I have to give a little bit of a ride to my class. So I'll see you on next week for this very same time, like 3:15. Still we are in the vacation. Right, so we'll discuss about the input devices and we'll see how to assemble a computer on that day. Right, so thank you very much, people. Have a very nice evening, and I'll see you on next week for the very same time. Right, thank you very much, everyone. Okay, Rison, thank you very much. I'm going to end the session quickly, people. So thank you very much.